Okay, so this is a little bit meaning close to zero, not zero, close to zero, tiny. So then Q and P and Q are something like this. P is here, Q is here. Very close to each other. But I have to zoom in order to explain what I'm doing. So we can take a note or put a note here that P and Q are close to one another. Okay. Can anyone give us the coordinate, the y coordinate of Q now?
F of x plus h.
Very good, f of x plus h. And now I'm going to connect these two points through with a line that passes through them. This is called a secant line. Why it's called secant has nothing to do with trigonometry. We're not talking about secant x. We're talking about a line that crosses a graph in 2 points versus to a tangent line. How will a tangent line look like? A tangent line at P, for example, will look like this. The tangent line at P touches the graph of the function in only 1 point. A secant line is the graph is the line that crosses the function twice. Yeah, you can cross more than twice, but at least twice. Okay, this is the tangent because it only touches in 1 point. Okay. Now, I would like to determine the slope of the secant line PQ. Anyone remembers how we determine the slope of a line, of a straight line? And I will write the definition here. A line passing through 2 points.
Y2 minus Y1 over X2 minus Y1.
Excellent. Thank you, Sean. Very good. This is the slope of a line passing through 2 points. Slope of a line passing through 2 points. Perfect. So keeping this in mind, can anyone tell me how to write the slope of the secant line? This is the general definition of a slope of a line passing through 2 points, but now we want to write the slope of the secant line.
Would it be f of x plus h minus f of x over x plus h minus x?
Excellent. We simplify x with negative x. So the final simplified form is f of x plus h minus f of x divided by h. Before we write what this is, let's discuss what it means. What does it mean? So when we talk about the slope of a line passing through 2 points, we are really talking about the rate of change of a rise of a run, right? Of y with respect to x. Of y with respect to x. What does the rate of change mean? How fast y changes when we make a change in x. So if I go this way 1 mile, how much do I go up, right? So if I go this way 2 miles, how much do I go up? Rise over run. The rate of change of function y with respect to x. Okay. But now this is clearly what we call the difference quotient. This is the difference quotient. For any function between these 2 points, this function can be rational, can be linear, can be quadratic, can be polynomial, can be logarithmic, exponential, anything. For any function, f of x plus h minus f of x divided by h will represent the rate of change of that function between p and q, but p and q are very close to each other. They're not identical. So when we say a little bit, we automatically mean h does not equal 0. So please remember this. We really mean h to be a little bit, but not 0. So p and q are not identical. They're not the same point. So this is what we call the difference quotient. The definition again, the rate of change of y with respect to x between p and q, they being very close to each other. That's the difference quotient. Okay, now please choose any functions you want. So part 2, we want to calculate the difference quotient for different functions. So choose any function you want. It can be radical, it can be quadratic, it can be, for now, let's stick with quadratic, rational, radical. Quadratic functions, rational, and radical. So let's calculate for each. Make up one. Let's start with the quadratic. Make up any quadratic function that you think of, and let's calculate the difference quotient for that.
What about 2x squared plus 5x plus 4?
Excellent. Who was that?
Caitlin.
Very good. Great job. Okay. Good. So remember the difference quotient. You have to memorize it moving forward. It's f of x plus h minus f of x divided by h. Okay. Do I have this?
Yeah.
Yes, of course. Caitlin just gave it to us. I have it. All I have to do is change its sign when I put it here. Negative this, negative this, negative this. This I cannot change. This is it. Do I have this?
No.
No, I have to calculate it. Before you tell me what to write, let me tell you what I see in Caitlin's function. This is what I see in this function. If this color is not good, please tell me and I'll stop using it. So at any point in time, any color. So I have to change them frequently because otherwise they get dried up. They dry up quickly. That's why I'm changing the color all the time. This is what I see in her function. I see the pattern. She said the function of whatever is 2 times whatever squared plus 5 times whatever plus 4. That's the pattern she used to give us the function. And that's what I see. I don't care what x is. That's the pattern. That's what the function is telling me to do. Can anyone mimic this and tell me what to write in the preliminary stage? Don't calculate anything yet for everyone to see what we are writing.
Just say 2.
Say it again.
2 times
yes.
x plus h raised power 2 plus 5 times x plus h plus 4.
That's it. So I hope that everyone sees that. Thank you. Was that Isaac?
Yes.
Perfect. Thank you. Is it clear what I'm doing? Do you understand from here how we got to here?
You just substitute the x's for
Exactly.
x plus h
Excellent.
in the equation.
Exactly. Who was that? Natalie? Yes, of course.
Yeah, Natalie.
Yes, this is now my x. And now this is what we reviewed last time. Please square this for me without foiling, please. We discussed the formula last time, the special product. Please tell me what to write in a blink.
X squared
Squared
plus 8 plus 8 squared.
That's it. Plus 5x, plus 5h, and plus 4. Good. And finally, yes, you're going to tell me to distribute 2x squared plus 4xh plus 2h squared plus 5x plus 5h and plus 4. Yay, this is halfway through. Now I finally got this. So all this piece will replace this one here. And now I can put these three pieces together and determine the difference quotient. Before I do that, we have a big note to write. Note. Please remember this. This will save you a lot of grief moving forward. Okay, number one. Yes? Oh, shoot. Yeah, I touched this cable, but no, this is from a different camera. I'm not sure. I don't understand why this is happening to me. So all terms without h must simplify. If they don't, so this is a note for the difference quotient, of course, for the difference quotient. So all terms without h must simplify. Some terms with h must simplify as well. I don't care. But all terms without h must go away. If some terms with h go away too, that's a bonus. Fine. Number two, h from the denominator must simplify with h in the numerator. Three, if you want, there will always be an h left in the final form of the difference quotient, of course. What's all this? That sounds gibberish. So when I start putting the difference quotient together, because I have to determine it and simplify it, all terms without h must simplify somehow. I cannot erase them. I cannot disregard them. They must simplify. H from the denominator must go away somehow, not with a magic, but legitimate, of course. And there will always be an h left in the final answer. What did I write here? For difference quotient, I meant to write. Okay, so there must be an h left in the final answer. Of course, for the difference quotient. Okay, now, coming back to the function, coming back to the difference quotient, I will, instead of this, I will copy all this, then minus, I will distribute minus to these three terms, and then put h in the denominator. And let's see what happens next. So the difference quotient for this function is, I copy 2x squared plus 4xh plus 2h squared plus 5x plus 5h and plus 4, but minus 2x squared. And of course, you will always find out that I always run out of room. I always do. I write big so you can see, and then I always write out of room. So these, of course, are right here. Do not write them up there if you have room, and I'm sure you do. So 2x squared plus 4xh plus 2h squared, 5x, 5h plus 4. This was f of x plus h that we copied. And then minus the 3 terms in f of x divided by h. Note number 1 says all terms without h must simplify. Let's see. All terms without h are gone. How many terms are left? Do you notice something? Because now I have, go ahead.
They all have H in them.
They all have h in common. Awesome. Who was that?
Caitlin.
Thank you. Good. So what is left in parentheses? And remember, I have 3 terms. I better have 3 terms here. And the 3 terms are?
4x plus 2h plus 5.
So h from the denominator must simplify with an h in the numerator. That's it.
Your camera went off again.
Yeah. Thank you. I guess it's not the the hub. It's probably the camera. I'm not sure. Okay, so the final answer is number 3. There will always be an h left in the final answer for the difference quotient, and there is 4x plus 2h plus 5. And now if you say, what is this? Is the rate of change of the function that you just gave me between p and q. That's what it means. Okay, so either a rational function or a radical or both. To see the process for these functions, radical and rational.